Mr. Moore's math class! Good evening, guys, and thank you very much for tuning into Mr. Moore's online flip classroom. Now, guys, we've got plenty to get through today because we're going to be learning all about domain and range. And this is actually a brand new concept to many of you. So let's not wait any longer and let's get stuck straight into the lesson and have a look at a little bit of a definition on what domain and range actually are. So let's check it out. So as you've just seen, guys, today we're learning all about function notation, and in particular we're going to cover things such as domain, range, maximum and minimum values. Now there's a few words that we might come across that you haven't seen before, such as domain, range, maximums and minimums. Pretty funny that, considering that's what the lesson's about. But of course there's going to be some other words such as local minimum, local maximum, codomain, and we're going to come across some things like round and square brackets, and they're going to have different effects on the way the graph looks. So what we're going to do now is we're going to go through and sketch the graph of y equals 1/3 multiplied by x minus 2 times x plus 1 times x plus 6. Now if I was to do that, I'd go through and find my x-intercepts by making y equal to 0, and I'd solve for x, giving me an x-coordinate at x equals 2, x equals -1, and x equals -6. Now what I'd do is go through and find my y-intercept by making x equal to 0, so therefore I'd do that and I'd simplify, which would give me a y value of -4, giving me the y-intercept at the coordinates 0, -4. Now I'll go through and sketch that by just joining the dots like so, and as you can see the graph there basically looks just like that. Take note that they've got the arrows, which means it continues up forever in this direction and continues down forever in this direction. Now what I want to discuss is a thing called local maximums and local minimums. Now, a local maximum is basically a turning point, as is a local minimum, because what happens is the graph goes all the way up, getting higher and higher and higher and higher and higher, until it gets to this point here, before coming back down again. Now this, as you can see, is a maximum point. But in comparison to this part over the graph over here, it's not actually the maximum point of the graph, because this continues up higher than what you could see before. So, because it's just a maximum point, but it's only maximum at that area, in that local area, it's called a local maximum. As I go down the graph now, you can see that it goes down, 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 until it gets to a minimum point just over here. Now once again, it's a minimum point just for this area, because if we come over here, you can see the graph actually does go lower than that value. So because it's a minimum point just in this local area, it's a local minimum. Now what we're going to discuss is a thing called domain and range. Now, in order to be able to talk about domain and range, basically we're just talking about x and y values. So for our domain, basically what that means is what x values does the graph exist for? And we can always tell this by just drawing a line. So if I come to -8 and draw a line straight down and I can hit the graph, well therefore my graph exists at that value. Now this arrow basically means that the graph will continue going along forever along the x-axis and also forever along the y-axis in the negative direction. So because of that, my graph exists for all negative values of x. Now as I come over here, what you can see is my graph is going to exist for all positive values of x, because if I draw a line up for any value of x, I'll eventually hit the graph, and we know that because the arrow here. Now the same for the range. I want to find out what y values does the graph exist for. Well, it's going to go at -15. You can see there it's going to hit the graph. At -6 it's going to hit the graph. At 12 it's going to hit the graph. And at 15 it's going to hit the graph. And of course, because of the arrows, this means it continues on forever in both directions. So that means the range is going to exist from -infinity all the way to infinity. So therefore we say that the range is real. So now what we're going to do is have a look at what occurs when we restrict the domain of a function. So as you can see here, I've written out a whole lot of mumbo jumbo, but some of this should actually look familiar to you, because what you've got here is f of x is equal to x minus 1 multiplied by x plus 3 multiplied by x minus 2. Now this section here is actually no different to anything that you've seen before. The only thing that is different is this first little section here, and what that basically represents is what area we're going to sketch the graph for. That is what x values we're going to sketch the graph for. So there's a few things that we need to know first of all. Now the very first thing is that the f of x, or the f here, are both known as the name of the function. So for example, if I call this g of x, this would also be g out the front here. The next thing that we need to know is the domain. Now the domain is represented by this little section here, and what that's telling us is that we can only sketch this function that you can see over here, but for any x value between -4 and 1. The next thing that we need to know is a thing called the codomain. And this isn't too important because it's generally just any r value. That is, if I substitute in any x value between negative 4 and 1, what that means is I can get any real value for y. So essentially summing that up, what this little section here tells us is our x values that the graph exists for, and what this will tell us is our possible y values that it could exist for. The other thing that we need to know, of course, is the rule, and this is going to tell us what the graph is actually going to look like. So now what I'm going to do is go through and sketch the function once again of f of x is equal to 1/3 multiplied by x minus 2 times x plus 1 times x plus 6. And of course, what I've done now is I've actually included the domain and the codomain, where the domain is equal to r, and my codomain is equal to r as well. So what that means is I can sketch the graph for any real value of x that will give me any real value of y. So if we have a think about this, the graph actually hasn't changed at all from what we had before, because for this whole graph, what you can see here is I can get any real value of x will actually end up hitting the graph. So my domain hasn't changed, so my domain is r. And my range, well, my range is equal to r as well, because the graph will exist for any real value of y. So now what we're going to do is we're going to sketch the same graph as what we sketched before, but we're actually going to restrict the domain for any x value between negative 6 and 3. So we'll get our axis right now and we'll plot the graph that we had before, that is where the domain was between any real value. So now what we're going to do is restrict the domain, like I said, between negative 6 and 3. So I'm going to get rid of any x value less than negative 6, and I'm going to get rid of any x value greater than 3. Now if we have a look up here, this square bracket means that the x value of negative 6 is actually included. Therefore, we represent this on the graph by using a coloured in dot, as you can see just down here. Now if we have a look over here, we've got the round bracket that you can see here. Now that means that the graph at x equals 3 is not included, and we represent this on the graph by having an empty dot. So let's get rid of the lines now, and this is what the graph will actually look like. So now if we have a think about it, well, what's our domain going to be? Well, it's going to go from any x value from negative 6 all the way over to 3. So our domain is from negative 6 to 3. That is with a square bracket at negative 6 and a round bracket at 3. Now our range, well, what's our lowest y value going to be? Well, it's over here, and that looks to be at y equals negative 5. And our maximum y value, well, that looks to be at y equals 12 over here. And of course, because it's turning points, it means it's actually included. So our range is going to be from negative 5 to 12 with square brackets. So once again, I'm going to sketch the graph of f of x is equal to 1/3 times x minus 2 multiplied by x plus 1 times x plus 6. But in this case, what I'm going to do is restrict the domain to between x equals negative 4 and x equals 2. So let's go through and plot the axis once again, and we'll plot the original graph. But this time, like I said, I'm going to restrict the domain between negative 4 and x equals 2. So let's go through and do that. Get rid of everything lower than negative 4 and everything above x equals 2. Now if we have a look at it, we've got a square bracket here, so that means we're going to have a coloured in dot at x equals negative 4, and a square bracket here, so therefore we're going to have a coloured in dot at x equals 2. So now let's have a think about this. What's our domain going to be? Well, it's going to be from x equals negative 4 over to x equals 2. So our domain will be from negative 4 to 2 with square brackets because they're both coloured in dots. Now what's our range going to be? Well, it's going all the way down here from y equals negative 5 all the way up to y equals 12. And because it's a turning point here and it's a coloured in dot here, it's going to be in square brackets. So it's going to be domain is equal to negative 5 in square bracket up to 12 with a square bracket. So in this example, what I'm going to do is I'm going to sketch the same graph once again, but for this one, what I'm going to do is actually restrict the domain from negative 6.5 to negative 1 and have them both not inclusive. So let's go through and plot the axis, and then we'll sketch the graph. Now because the domain goes from negative 6.5 to negative 1 along the x-axis, what I'm going to do is get rid of everything below negative 6.5 and everything above x equals negative 1. Now, as you can see here up the top, what we've got is two round brackets. So therefore, at negative 6.5, we're going to have an empty dot. And at x equals negative 1, we're also going to have an empty dot because it's not included, as I said, because of the round brackets. So let's get rid of the lines now. And what we can see here is what the graph should actually look like. So if we have a think about this now, our domain goes from x equals negative 6.5 up to x equals negative 1. And because they're both empty dots, it means that they're not included. So the domain should be with a round bracket at negative 6.5 and a round bracket at negative 1. Now our range, well, if we have a look down here, it goes from around about 7.8 or so all the way up to 12, and 12 is included. And of course, because this is an empty dot, it's not included. So our domain is from negative 7.8 up to 12, where 12 is included. Now, in order to get this negative 7.8, what you'd need to do is just substitute in negative 6.5 into this equation up here, and that would actually give you this value that you can see here. Now, for this example, what you can see is I've actually left my domain as any real value, but I've actually changed my codomain from negative 6 to 9, where negative 6 is not included, but 9 is included. And of course, once again, I've left it just as the same function as what we've been doing, just so you can see the difference. So let's go through and plot the axis and the original graph once again. Now, like I said, because I've changed my codomain, it means what we're going to do is actually get rid of some y values. So I'm going to get rid of any y value below negative 6, so let's do that. And I'm going to get rid of any y value above 9. So there you go, I've wiped out everything that I don't need now. And let's go through and plot the dots that we need to place. Now, of course, anything from negative 6 and below is not included. So because this is a round bracket, what we've got is a empty dot. And for this 9 here, because 9 is actually included, we're going to have coloured in dots for each of one of these places along here. So let's put in some coloured dots. 1, 2, 3. And we'll get rid of the lines now. So this is what the graph will actually look like when we take into consideration the codomain rather than the domain. So now if we have a think about the actual domain, well, we can see here it's going to go from negative 6 up to around about negative 5, and then as well from negative 3 all the way across to 3. So in order to write that, what we're going to say is the domain is from negative 6.5 to negative 5, and of course negative 6.5 is not included, hence the round bracket, up to negative 5 where it is included, hence the square bracket, union with, which means as well as, negative 3 where it's actually included because it's a coloured in dot and a square bracket, all the way over to x equals 3, which is once again a square bracket because it's a coloured in dot. Now the range, well, that's going to go all the way from negative 6 up to 9, that is all the way from here up to here. And of course negative 6, well, that's actually a round bracket, and 9 is actually a square bracket because it's included, as you can see by the coloured in dots. So as you can see, we've covered a whole bunch of things in today's lesson. That is, we've looked at the domain, which is basically how far along the x-axis the graph goes. We've looked at the range, which is how far up the y-axis the graph goes from the lowest point up to the highest point. We've looked at the maximums, which is the maximum value for y that the graph actually shows, and the minimum value for y, that is the minimum. We've also looked at the local minimum, which is basically a turning point that looks like it's a minimum point at that value, but actually is not the absolute minimum for the graph. And the local maximum, which is the same but a maximum turning point. And we've looked at the codomain, which is any y value that can be obtained when substituting into the rule. And we've also looked at the round and square brackets and also the empty and coloured in dots and how these look when we're sketching the graphs using function notation.